half plus minus 1 by 6 plus minus 1 by 24 plus minus 1 by 120 plus to infinity. Okay. And for this, here a1 is equal to a2 equal to 2, an is equal to a n minus 1 minus 1 and n greater than 2. So here we will take the value of n after 2, that means from 3. Okay, so a3 equal to a3 minus 1 minus 1, that means a2 minus 1. Here a2 equal to 2, so 2 minus 1 equal to 1. a4 equal to a4 minus 1 minus 1, that means a3 minus 1. Here a3 equal to 1, so 1 minus 1 equal to 0, and a5 equal to a5 minus 1 by minus 1, so a4 minus 1, that means 0 minus 1 equal to minus 1. So we have find up to 5 terms, first 5 terms. Okay, so the corresponding series will be here a1 equal to 2 plus 2 plus here a3 equal to 1 plus a4 equal to 0 plus a5 equal to minus 1 plus dot 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 up to that will be the answer. Okay, and welcome back to our channel anganastudycente. Today we will learn about the sequence and series class 11 8th number chapter. Okay, in previous class we have learned the arithmetic progression, okay, arithmetic mean, etc. In this class we have learned about the sequence and series. So first we will learn about the sequence, okay, and then we will learn about the series. Okay, let there are some terms, suppose a1, a2, a3, an, are some terms. Okay, we write the comma between two terms. Okay, if there is an expression like this, then this is called a sequence. Okay, called a sequence. Okay, this subscript, that is 1, 2, 3, 4 up to infinity. The subscript represent the position of the term in sequence. Okay, so here we have written an. N is the in it. An is the nth term. Okay, so an is the nth term of the sequence. Okay, suppose we have a sequence of even natural numbers, that means 2, 4, 6, 8 up to infinity. Okay, then the nth term of this sequence n is equal to 2n, where n belongs to n, that means n is a natural number. Okay, and if we write 1, 3, 5, 7, 9, dot 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 dot, here this is the sequence of odd natural number, and the nth term is represented by 2n minus 1 when n belongs to n. Okay, here we have seen a particular pattern in these two. Okay, here the next term is greater than the previous term, and if we add 2 with the first term, then we get the next term. And here also, if we add 2 with the first term, we get the second. If add 2 with the second term, then get the third. Similarly, we have seen a particular pattern. Okay, if there is 2, 3, 5, 7, dot dot dot, that is the sequence of all prime number. Sequence of prime number. Are we found any particular pattern in this? Absolutely no. There is no particular pattern. This is only a verbal sequence. Okay, we can't find the nth term of this sequence. Okay, as there is no particular pattern. Okay, so up to this, is this clear? Okay, now sequences are of two types. One, finite, and second infinite. Okay. So what is finite? If a sequence containing finite number of terms. Okay. Then if a sequence 1, 2, 3, 4 and 5, then it is the terms are countable. So this is a finite sequence. Okay. If a sequence is not finite, then that is infinite. That means the terms are not countable. Okay. If there is 1, 2, 3, 4, 5 up to infinity, so it is a infinite sequence. Okay. In the previous sequence of even natural number and odd natural number, there are the visual pattern, and there is also a sequence where we can't find any visual pattern. Just look. If an is equal to an minus 2 plus an minus 1, when n greater than 2, okay, and a1 is equal to a2 is equal to 1, okay. Then look here, a1 is equal to a2 is equal to 1. So if we write the sequence, then that will be 1 comma 1, and the a3 term will be a3 minus 2 1 plus a 3 minus 1 a2, that means 2. So 2 a4 is equal to a2 plus a3 1 plus 2, that means 3. Here just look, in the sequence there is no visual pattern. Okay, there is no visual pattern. Okay, no visual pattern. Okay, this type of sequence is called Fibonacci sequence. Okay, clear? So we have learned about the finite, infinite and Fibonacci sequence. Okay, now we will move to the series. In sequence we have seen that there is a1, a2, a1 comma a2 comma a3 up to an up to infinity. Okay, so every term is separated by comma. This type of expression is called sequence. But in series, let a1, a2, an up to infinity are in sequence. Okay, that means these terms are in sequence. Then the series associated with the sequence is a1 plus a2 plus plus an plus . Okay, so if we write this term like this, then this is called a series. Okay, here this series can be written as this sign. This sign is called the sigma. Okay, this is a sign of sigma. By seeing this, we generally say this is the summation sign, but it is not summation. It just indicating the summation. Okay, but not the summation of these terms. Okay, clear? Here, just see. If there is a question, the sum of the series 1 plus 2 plus 3 plus 4 plus 5. What is the sum of the series? Okay, then we may say the sum of the series is equal to 9, 14, 15. Okay, here the sum of the series, but this is not sum of the particular this sum of these terms. Okay, it is the indicating the summation. Okay, here like sequence, the series are of two types, that is finite and infinite. Okay, a series is called finite associated with a sequence when the terms are countable. That means terms are finite. Okay, then that series is called finite series, and a series is called infinite when that is not finite. Okay, that means the terms are not countable. Okay, clear? Look at this example. Write the first three terms in each of the following sequence defined by the following. Here, an represent the nth term. Okay, so just put here the here we have seen n belong to capital N, that means natural number. So here in the place of n we put 1, 2, 3 and find the value. Okay, so we will get the terms. We have seen a1, a2, a3 dot up to an to infinity. That's at the term. So to find the a1 term, just write here a1 equal to, here we put 1 in the place of n, and similarly in the place of n we put 1. So 2 into 1 plus 5. The value will be 2 plus 5 equal to 7. So the first term we have got. And similarly a2 equal to, just putting here in the place of n we put 2. So just 2 into 2 plus 5, that means 4 plus 5, that means 9. a3 equal to 2 into 3 plus 5, that means 11. So here is three terms. So we have found a1, a2 and a3. So the terms are 7, 9 and 11. The three terms are 7, 9 and 11. Okay, have three terms. Okay, and similarly let's put here a1 equal to 1 minus 3 by 4, that means minus 2 by 4, that means minus 5. a2 equal to 2 minus 3, that means 1 by 4. a3 equal to 3 minus 3 by 4 equal to 0. So the terms are minus half, minus 1 by 4, 0. Okay, very easy. Here, what is the 20th term of the sequence defined by an equal to n minus 1, 2 minus n into 3 plus n? So this is the nth term. To find any term, just put the position of the term in place of n. Okay, so here the 20th term is a20. Okay, so just in the place of n we put 20. So we'll get 20 minus 1, 2 minus 20, 3 plus 20. So this value will be 19 into minus 18 into 23. That means minus 7, 8, 6, 6. Okay, this will be the answer. See, let a sequence is defined as follows: a1 is equal to 1, an is equal to an minus 1 plus 2. For n greater equal to 2, here just see the value of n. N greater equal to 2. That means the value of n will be 2, 3, 4 up to infinity. Okay, and just see, find the first 5 terms and write the corresponding series. So we have previously learned to find out the terms. So here a1 is equal to 1, that is given, and we will found the a2, a3, a4 as n greater equal to 2. So we will find the a2 term first. a2 equal to a2 minus 1 plus 2, that means a1 plus 2. Here given a1 is equal to 1, just put the value 1 plus 2, that means okay. a3 equal to a3 minus 1 plus 2, that means a2 plus 2. Here a2 equal to 3, so just put 3 plus 2 equal to 5. Now a4 equal to a4 minus 1 plus 2, that means a3 plus 2, that means a3 equal to 5, 5 plus 2 equal to 7. a5 equal to a5 minus 1 plus 2, that means a4 plus 2, that means 7 plus 2 equal to 9. So we will find the 5 terms. Okay, so the 5 terms are 1, 5 terms of the sequence. Sequence are 1, 3, 5, 7 and 9. Okay, and here write the corresponding series. So we have seen the series can be expressed as with the sign of plus. So the corresponding series will be 1 plus 3 plus 5 plus 7 plus 9 plus up to infinity. Okay, and here n greater equal to 2. So the value of n up to infinity. So this series will be like that. Okay. Now we will do the exercise number 8.1 of your NCERT textbook. Okay. Just look at this question. Write the first 5 terms of each of the sequence in exercise 1 to 6 whose nth terms are n equal to n into n plus 2, n is equal to n by n plus 1, n is equal to 2 to the power n is equal to 2n minus 3 by 6, n is equal to minus 1 to the power n minus 1, 5 to the power n plus 1, and n is equal to n into n square plus 5 by 4. So just we have to find the first 5 terms. That means a1, a2, a2, a3, a4, a5. Okay. So here a1 equal to just write 1 in place of n. So this will be 3. A2 equal to just write 2 in place of n. And 2 plus 2 equal to 8. 3 equal to 3 into 3 plus 2. That means 15. A4 equal to 4 into 4 plus 2. 24. A5 equal to 5 into 5 plus 2. 35. Okay. So the 5 terms are 3, 6, 15, 24 and 35. And mean 3, 6, 15 or 24, 35. Okay, the 5 terms are. Okay. This second, similarly, a1 equal to just putting 1 in place of n, 1 plus 1, that means up. A2 equal to 2, 2 plus 1, that means 2 by 3. A3 equal to 3, 3 plus 1, that means b4. A4 equal to 4 by 4 plus 1, that means 4 by 5. A5 equal to 5 by 5 plus 1 equal to 5 by 6. Okay, so the first 5 terms are half. 2 by 3, 3 by 4, 4 by 5 and 5 by 6. Okay. So this time here a1 is equal to 2 to the power 1 equal to 2, a2 equal to 2 square equal to 4, a3 equal to 2 cube equal to 8, a4 equal to 2 to the power 4 equal to 16, a5 equal to 2 to the power 5 equal to 32. Okay, the terms are 2, 4, 8, 16 and 32. And for this, a1 is equal to 2 into 1 minus 3 by 6, that means minus 1 by 6. A2 equal to 4 minus 3 by 6, that means 1 by 6. A3 equal to 2 into 3 minus 3 by 6, that means 6 minus 3, that means 3 by 6, that means half. A4 equal to 2 into 4 minus 3 by 6, that means 8 minus 3, 5 by 6. A5 equal to 2 into 5 minus 3 by 6, that means 7 by 6. Okay. Similarly, A1 equal to here minus 1 to the power 1 minus 1, 5 to the power 1 plus 1. That means 1 minus 1 equal to 0, minus 1 to the power 0 equal to 1, and 5, 1 plus 1, 2, that means 5 square equal to 25. A2 equal to minus 1 to the power 2 minus 1, 5 to the power 3 equal to here minus 1 to the power 1 is equal to minus 1, and 5 cube equal to 125 equal to minus 125. Okay. A3 equal to minus 1 to the power 3 minus 1 into 5 to the power 3 plus 1, that means 4. Okay. So here 3 minus 1 equal to 2, minus 1 square equal to minus 1 into minus 1, that means plus, and 5 to the power 4 equal to 25 square, that means 6 to 5. A4 equal to minus 1 to the power 4 minus 1 into 5 to the power 5, that means cube equal to minus 1. So minus 1 into 625 into 5 equal to, that means minus 3125. And A5 equal to minus 1 to the power 5 minus 1, that means minus 1 to the power 4, that means plus 1 into 5 to the power 6, that means minus plus 3125 into 5, that means 15,625. Okay. And for this, A1 equal to 1 into 1 plus 5 by 4, that means 6 by 4, that means 3 by 2. A2 equal to 2 into 4 plus 5 by 4, that means you will be cancelled out 9 by 2. A3 equal to 3 into 9 plus 5 by 4, that means 14, 7 by 2, 21 by 2. A4 equal to 4 into 16 plus 5 by 4, 4 will be cancelled out, and here will be 21. A5 equal to 5 into 25 plus 5 by 4, equal to 5 into 30 by 4, that means 75 by 2. Okay, this will be the first 5 terms of the sequence. Okay, let's look at this question. Find the indicated term in each of the sequence in exercise 7 to exercise 10 whose unit term are given. N is equal to 4n minus 3. We have to find A17 and A24. That means the 17th term and 24th term. Here an is equal to n square by 2 to the power n. Find, we will find the A7. That means the 7th term. Here n is equal to minus 1 to the power n minus 1 into n cube. And we will find the A9. That means the 9th term. And here an is equal to n into n minus 2 divided by n plus 3. And we will find the A20 term. Okay. We have previously known the to find the nth term and in particular term. Okay. So here A17 equal to, just put the 17 in place of n. So here will be 4 into 17 minus 3. 68 minus 3 equal to 65. And A24 equal to, just put 24 in place of n. 4 into 24 minus 3. That means 96 minus 3 equal to 93. Very easy. Okay. Similarly, here A7 equal to, just put 7 in place of n. 7 square 2 to the power 7 equal to 49 divided by 32 into 4. So 49 divided by 128. Okay. Here we will find the 9th term. That means A9 equal to minus 1 to the power, in place of n we will put the 9. So 9 minus 1 and here 9 cube. Okay. So we have minus 1 to the power 8 into 9 cube. So minus 1 to the power 8 as the power is given. So minus will be plus. So this will be 1 into 81 into 9. That means 9. 7 to 9 will be the answer. And for this, we will find the 20th term. That means A20. Okay. Just put 20 in place of n. 20 into 20 minus 2 divided by 20 plus 3. That means 20 into 18 divided by 23. That means this is 60 divided by 23. Okay, very easy. Let's look at this question. Write the first 5 terms of each of the sequence in exercise 11 to 13 and obtain the corresponding series. So in previous example and exercise we have learned to find the terms. Okay. Here also a question. Here you have to show the corresponding series also. So first we will find the terms and then show the series. Okay. So here A1 is given and an equal to 3, a n minus 1 plus 2 for all n greater than 1. So the value of n we should take from 2. Okay. So if we take 2, so a2 equal to 3 into a2 minus 1 plus 2. That means 3 a1 plus 2. Here a1 is equal to 3. So 3 into 3 plus 2. That means 11. A3 equal to 3 into a3 minus 1 plus 2. That means 3 into a2 plus 2. That means 3 into 11 plus 2. Okay. That means 35. A4 equal to 3 into a4 minus 1 plus 2. That means 3 into a3 plus 2. That means 3 into 35 plus 2. Okay. So 107. And a5 equal to 3 into a5 minus 1 plus 2. That means 3 into a4 plus 2. That means 3 into 107 plus 2. So 323. So the corresponding series will be a1 equal to 3. So 3 plus 11 plus 35 plus 107 plus 323 plus up to dot dot dot. Okay. And for this, here a1 is equal to minus 1. A is equal to an minus 1 by n, but n greater than equal to 2. So here we will take the value of n from 2 to up to n. Okay. So we first find the first 5 terms. Okay. So here a2 equal to a2 minus 1 by 2. So a1 by 2. That means minus 1 by 2. a3 equal to a3 minus 1 by 3. That means a2 divided by 3. That means minus half. divided by 3, that means minus 1 by 6. And A4 equal to A4 minus 1 by 4, that means A3 by 4, that means minus 1 by 6 by 4, that means minus 1 by 24. A5 equal to A5 minus 1 by 5, that means A4 by 5, that means minus 1 by 24 by 5, so minus 1 by 120. So the corresponding series will be here minus 1 plus minus half plus minus 1 by 6 plus minus 1 by 24 plus minus 1 by 120 plus up to infinity. Okay. And for this, here A1 is equal to A2 equal to 2, An is equal to A n minus 1 minus 1 and n greater than 2. So here we will take the value of n after 2, that means from 3. Okay. So A3 equal to A3 minus 1 minus 1, that means A2 minus 1. Here A2 equal to 2, so 2 minus 1 equal to 1. A4 equal to A4 minus 1 minus 1, that means A3 minus 1. Here A3 equal to 1, so 1 minus 1 equal to 0. And A5 equal to A5 minus 1 by minus 1, so A4 minus 1, that means 0 minus 1 equal to minus 1. So we have find up to 5 terms, up 5 terms. Okay, so the corresponding series will be here A1 equal to 2 plus 2 plus here A3 equal to 1 plus A4 equal to 0 plus A5 equal to minus 1 plus dot up to infinity. That will be the answer. Okay. Look at this question. The Fibonacci sequence is defined by. We have learned about the Fibonacci sequence. There is no visual pattern. Okay. Here, then look, A1 is equal to A2 is equal to 1 and An is equal to A n minus 2 plus A n minus 1. Where n greater than 2. Okay. Find A n plus 1 by A n. For n equal to 1 to 5. So we have to find this term when n is equal to 1, when n is equal to 2, when n is equal to 3, when n is equal to 4, when n is equal to 6. So here, then look, we first find this term. Okay, let when n is equal to 1, a n plus 1 divided by a n equal to here a n equal to 1, that means 1 plus 1 by a 1. So a 2 by a1. When n equal to 2, this will be a n plus 1 by a n equal to a3 divided by a2. When n is equal to 3, a n plus 1 by a n equal to here 3 plus 1, that means a4 by a3. And n4 equal n equal to 4. When n equal to 4, a n plus 1 divided by a n is equal to a5 by a4. When n is equal to 5, a n plus 1 divided by a n equal to a6 by a5. So here we have find we have to find the 6th term, that means a6 up to 6th term. So we will find the 6th term first. Just here n greater than 2. So we will find the term from the 3rd term, that means a3. Okay, here a3 equal to, just put here the 3 in place of n. So here n equal to 3 minus 2 plus a 3 minus 1. So this will be a1 plus a2. Here given a1 is equal to a2 equal to 1. So just put here 1 plus 1. Now a4. A4 will be the a4 minus 2 plus a4 minus 1. So a2 plus a3. Here a2, the value of a2 equal to 1, and we have just find the a3 equal to 2. So this will be 3. A5 equal to a5 minus 2 plus a5 minus 1. So this will be a3 plus a4. We have just find a3 2 and the value of a4 equal to 3, that means 5, and a6 equal to a6 minus 2 plus a6 minus 1. So this will be a4 plus a5. A4 equal to, we have find 3 and a5 equal to 5. So that will be 8. So just put the value of this here. A2 equal to 1 and A1 equal to 1. So 1 by 1 equal to 1. For this, A3 by A2. A3 equal to 2 and A2 equal to 1, so this will be 2, and here A4 by A3, A4 equal to 3, and here A3 equal to 2, so 3 by 2, and for this A5 by A4, A5 equal to 5 and A4 equal to 3, and here A6 by 5, A6 equal to 8 and A5 equal to 5, so that will be the answer. 1, 2, 3 by 2, 5 by 3 and 8 by 5. Okay, so that's all for today's class. We have learned about the sequence series, and we also learned to find the nth term, that means any position of term in sequence, and we have also learned about the series from a sequence, how to express. Okay, so just practice all of this we have covered in this class. If you like this video, please press the like button and subscribe our channel and share with your friends.